Hi, my name is Richard Saxon. I'm the coordinator of the Automotive Technology program at the Community College of Philadelphia. In today's episode of Car Corner, you're going to see Mr. Dan Reed explain what's behind that mysterious check engine light. If you have any other questions about the Automotive Technology program, please contact us at the website.
Hi, I'm Dan Reed with the Community College of Philadelphia. Welcome to Car Corner. Today, we're going to be talking about automotive sensors and tools to use to diagnose them. And first, you have to understand that sensors are necessary. If you think about the human body and our own sensory inputs, sight, taste, touch, smell, hearing, those are all inputs, and they're what we use to navigate the world around us. Car sensors work the same way. They just don't necessarily see and touch the same things that we do. They work a little bit differently. And when there's a problem, sometimes it can be a big repair, fairly costly, or sometimes it can be a fairly simple, easy repair. And sometimes, just like the human body, your brain may be telling you something is wrong, but the fact is there's actually a problem with something else, and it may not even be a major issue. So first, let's take a look at some of the basic tools that we're going to use to take a look at some of the automotive sensors in cars today. The first and most basic tool is over here. This is a digital multimeter, and the digital multimeter is basically a tool that just measures different types of electricity. Car sensors work on electricity. They take physical information and transfer it into electrical signals and then send that to a central computer, and the central computer figures out what to do with it, just like the human brain. The next step up is a scan tool. And the scan tool is a handheld portable computer that's dedicated just to basically talk to the car's automotive electrical systems and sensors. If the scan tool detects a problem, it's going to basically convert that electrical signal from the car into English or any other language that the technician can understand. And from there, the technician is going to go through and repair the vehicle. A lot of people think that the computer, the scan tool that the technician uses, is what actually fixes the car, and the fact is it doesn't do that at all. The scan tool just informs the technician as to what the problem is and if the sensor's working or not, and then from there the technician has to figure out what the actual fault is. And I'll show you how this tool works in a little bit. The next tool that we have in the evolution of scan tools is really just a plain old laptop. And what manufacturers realized is that every couple of years or so they would have to come up with a new type of scan tool because the electronics got more complex in the cars. What they realized is that if they just used a laptop, they could just upgrade the software on a laptop just like there would be an upgrade for an operating system or something to fix a computer bug. And what they do is they use a special interface cable to actually connect the laptop to the car, and from there the computer can go through and basically act as the scan tool. Couple disadvantages to the laptop. One, it's a laptop. It's just a regular computer, so it's not real ruggedized for the shop environment, and there are models that are made for that, and they're pretty costly. The other thing is that this portable scan tool, this is real easy to take with me in the car and maybe have somebody sit in the passenger seat and look at the sensor data while I'm going down the road, and it's just a little easier to control. It almost has like a video game style setup for the control panel here, as opposed to having to punch a bunch of buttons. One of the last pieces, which is really important, and you cannot fix the car without it, this is the service manual for the vehicle that we're going to be using today. And you can see it's fairly thick, okay? And what you may think about this is, boy, there's a lot of information in this book. And the fact is there is a lot of information. In fact, this is pretty much everything there is to know about the car as a whole, not just the sensors. But if you don't have the information and you don't have the tools, you really can't even start to fix a modern car today if there's a sensor problem. The way most people know that there's a sensor problem with their car is because the check engine light comes on the dashboard. And when cars first started having check engine lights federally mandated starting in the 1996 model year, the light would come on and people would go out and check the oil, and the oil would be okay and they would just keep driving the car. But the fact is if that light comes on, there's a problem, the computer's detected a fault, and basically, I like to call that the money light. And not because it costs a lot of money to fix it, but the fact is, if that light is on, your car is either polluting or wasting gas, and it's costing you more money, okay? Check engine light is a universal symbol on all vehicle dashboards that either says the words check engine or has a picture of an engine symbol with a little lightning bolt, and it may say the words check underneath it. There's other warning lights on the dashboard. There's a battery light and an oil can light or an oil pressure light. And these lights do not mean the same thing as the check engine light. A lot of people make that mistake. There's also maybe another light known as a maintenance required light, which is not the same thing as a check engine light. That's from the manufacturer telling you that it's time to get the oil changed or time to change an air filter. And that's generally set by mileage. Now, if the check engine light comes on while you're driving, as long as the car is operating properly, you can still safely drive that car. Just make sure that as soon as you can, you get it looked at, because if the light stays on for too long, it's going to end up costing you money. The only time that you really have to be concerned about it is if the check engine light is flashing on and off. If the check engine light is flashing on and off about once per second while you're driving, stop driving the car. That light is flashing for a reason. It's designed to get your attention. It's designed to scare you a little bit. But the fact is if you're driving and that light is flashing, you're actually damaging expensive parts of the car. Typically the catalytic converter or other emission system components that can be extremely costly to repair. So just pay attention to the check engine light. So what we're going to look at next is we're going to look at some of the history involved with the actual sensors and how we moved from where we used to have cars with carburetors to where we are today. Okay, so now we've got some items set up here, going through the history a little bit, a very abbreviated history of automotive technology. And a lot of people, they think they know the names of car parts, and one car part that most people are familiar with even still today is something called a carburetor. And this is a carburetor. All right, this is an older, what was known as a two-barrel carburetor. It had two holes for the air and fuel mixture to go through. And carburetors were on vehicles, gas-powered vehicles, and they still are on some gas-powered vehicles for almost since the beginning of time. And what a carburetor does is it takes in a mixture of air. Air comes in through the top, and then there's this area right here, which is called the fuel bowl. And down on the inside here of the carburetor are two little feed horns. And the fuel would sit in this bowl and get sucked through those feed horns. And as you stepped on the gas, you would open up a set of throttle plates and allow that air and fuel mixture to get sucked down into the engine where it would be burned. And on the surface, carburetors are a really simple, elegant idea. I mean, you can see that there isn't a single wire on this carburetor to make it work. It's purely mechanical, which was good when we didn't have electronics. But the trade-off is, and the big problem with carburetors was that when you rebuilt a carburetor or got a new one, it was brand new. It was like a brand new mechanical clock, and everything in it would work perfectly. And there were people like my grandfather that could rebuild these things in 15 minutes with his eyes closed. But the problem is once you put them on the car and you got them tuned, from that point on, their performance started to degrade a little bit. And eventually they would get to the point where they would run so poorly and they would pollute so much and they would waste so much fuel that really wasn't good for the environment or the customer. But the problem is the car still actually ran. And it didn't give any indication on the dashboard that there was a problem. So customers would be driving around with poorly performing carburetors for a long time. Then they would have to get a tune-up, get the carburetor rebuilt. And at one point in time, it was not uncommon to rebuild these every 15,000 miles. If you think about a modern car today, you're going to get maybe 2 oil changes in that time, 2 oil changes. If you had to rebuild a major part on your car every 2 oil changes, you wouldn't be very happy. So it's something to be said about carburetors. They work a little bit like a toilet. Some people kind of get offended at that, but the fact is that's how they work. Fuel gas comes in through this part here, which is a fuel filter, and it travels inside this bowl. Inside this bowl, there's a float on a lever. So it's like the tank float inside the toilet. And when you step on the gas, basically you tell that float to allow more gas to flow through the carburetor, and it's like flushing the toilet handle. The gas and, in this case, the water and the waste goes down into the engine. And pretty much that's how they worked, how they were designed to work. Later on, this is a later carburetor on an intake manifold. You can see it's a bit more complex. It does start to have some wires and some tubes attached to it. And this was because the federal government really started to get strict with carburetors. And they said, look, to the manufacturers, you got to clean up your act here. These things they're polluting too much. And carburetors became incredibly complex. I mean, they went from simple mechanical units to overly complex mechanical units in a matter of just 5 years. And eventually, we did away with them. Okay, we moved on to electronic fuel injection. Now, electronic fuel injection really was pioneered in the 60s and started to become popular in automobiles in the 70s and even more popular in the 80s. And generally by the 90s, it was in everything that we drove. The trade-off is that while we get consistent reliability, the car starts every time, it doesn't pollute all the time, it runs fairly well all the time, the trade-off is the parts are expensive when they fail. So what these are is this is what two automotive computers look like. If you think about what a household computer looks like, it looks very different. There is a connector port in the front for wires to go to, and the processor itself basically is just like the box of a home computer. It takes input signals like a mouse or a keyboard would for a home computer, and then does an output. It puts, letters, the internet, whatever up on the screen or a printer. That's the output. So the automotive computer takes a sensor's input. This guy actually happens to measure airflow coming into the engine. It would send a signal through wires to the computer. The computer then would process that signal and then take that signal through a wire and then control an output. And our primary output on our car's computer are the fuel injectors. And these guys are just little electronic squirt guns that instead of having a mechanical carburetor control our fuel mixture, we just send a little pulse of electricity through a pressurized fuel rail, and it sprays an exact amount of fuel into each cylinder as it's needed. So it's a much more precise way to deliver fuel to the car as opposed to the carburetor, which worked, but like I said, it would wear out. The advantage to this is there's no moving parts. There isn't a single moving part in here. There's no moving parts in this. There's no moving parts in the computer. And while the fuel injectors, each one has one moving part that's just a little pintle that goes up and down. So it's a very reliable system from that standpoint. Okay? What we're going to take a look at when we come back is the individual sensors and what they do on the car and what can happen when they fail. Okay, so now we've got some basic parts set up here, and what we're going to look at first is the air that comes into the engine. Now, the air is going to enter through the vehicle's air box and then come through an air filter, where then it's going to get pulled through a throttle. Okay, and this is a typical throttle assembly right here. This guy, when you step on the gas, it opens up the throttle plates, and just like our mechanical carburetor, this allows a flow of air to come into the vehicle. Now, one of the things is that with modern fuel injection is the vehicle has to know exactly how much air actually came into the vehicle. When you step on the gas, you're really stepping on the air, and there's two key sensors that are going to tell the vehicle exactly what you want to do. I mean, that's one of the main inputs to the vehicle is stepping on the gas, saying, I want to go. So the first and most basic type of airflow sensor that we have is this guy, and this is called a vane air sensor. And this is, we used these for about 10 years when fuel injection first came out with some manufacturers, and there's just a little flapper door that opens, and as you step on the gas, the suction from the engine on the intake manifold would actually move this door open. And what we have on top here that I have taken away is we'll see that there's a small sensor wire that would move when that flapper door was open. So it would change a resistance, it would change an electrical signal that would get sent to the car's computer that would say, hey, you know what, right now the driver doesn't have his foot on the gas, and right now the driver has their foot all the way on the gas. We have a lot of air coming into the engine. So if we have a lot of air coming into the engine, we need to deliver more fuel. And pretty much that's what fuel injection does, is it measures that air and then calculates exactly how much fuel the car needs. But, you know, there's a problem with this. It's a moving part, okay? And moving parts are failure points. These things, they would get a little bit of moisture in them, and in the winter, they would freeze. And of course, they would freeze shut. You go to start your car, and it wouldn't work, okay? Unit was very expensive. These things from the dealer were probably, you know, on the upside of $400. And a lot of them probably got replaced unnecessarily because people just didn't understand how it worked or what it did. So what we moved on to next was we moved on to these two designs, and these are called mass airflow sensors. And what these do is these have no moving parts, but the air moves through this filtered screen, and the screen doesn't act like an air filter. What it does is it actually straightens the airflow out. We want the airflow to go straight across. And then what we have here is a little teeny tiny sensor. And this little sensor would detect how much air was moving through this tube. And based on that, it could do a calculation with the computer, and it would figure out exactly how much fuel, again, we needed to deliver. So basically, it did the same thing that this guy did, but it did it with no moving parts. So when it comes to cleaning these, there's a lot of misconceptions out there about, can they be cleaned? Are you supposed to clean them? And the fact is recently on the market, there is a product used for cleaning mass airflow sensors. In the past, what I've seen some people use is something like brake clean, which is okay for most plastics, but the fact is it'll actually damage the delicate sensor wire on the mass airflow sensor. And the absolute last thing you ever want to use to clean a car that's fuel injected is a carburetor cleaner type product like this product called Gum Cutter. And you really don't want to use that for cleaning a fuel injected vehicle. This stuff is fine for metals, but it literally disintegrates plastics, and we have too many plastic components in with our sensors today to safely use this. So what we have to clean mass airflow sensors is a proper product called mass airflow sensor cleaner. And what happens over time is the little sensor wire on the inside here, while it's supposed to be self-cleaning, it ends up with a little bit of dirt, a little bit of oil from the intake, and it starts to degrade the performance of the sensor. And by spraying this cleaning product, which really is just doesn't leave any residue behind and is safe for plastics, it really does a nice job on cleaning the sensor and keeping these guys in check. Now, if a sensor, if a mass airflow sensor had failed and it came into the shop, I might try cleaning it to see if the car runs any better. And at that point, I might leave it up to the customer as to whether or not they just want to go with the clean sensor or if they want to go ahead and replace it if it made a good enough difference, okay? The last thing that we have is, again, with our throttle plate here, there's two sensors that are often found on throttle plates. And just like our mass airflow sensor to tell the computer exactly how much air enters the engine, there's another key sensor called a throttle position sensor that's on the opposite side of the cross shaft from the throttle. So when I open and close the throttle like that, it actually moves a little lever on this black sensor right here. And there's three teeny tiny wires on the inside there that are going to send a signal back to the computer. And this is really what tells the computer exactly what you want to do. Okay, this, along with the amount of air coming into the engine, the car can really calculate pretty well the exact amount of fuel that it should deliver based on your demand. There's one other sensor that's sometimes found on the throttle bodies, and this little teeny tiny guy right here is called a MAP sensor. Okay, the MAP sensor is different than a MAF sensor. The MAF sensor stands for mass airflow, and MAP stands for manifold absolute pressure. This guy actually measures the pressure inside the intake manifold when the throttle's open and closed. If you remember back to physics class, when we have pressure drop on an object, its temperature changes, and that pressure change is able to be measured when we open the throttle. It's going to drop, and our pressure inside the intake is going to change a little bit. So this guy is sometimes found. Typically, a vehicle either has a MAP or a MAF. It doesn't have them both, so your vehicle may have one or the other. Okay? So there's one other thing that we can do with our throttle bodies, and that is we can also clean them. Now, you might think it might be a good idea to use the same cleaner I used to clean the mass airflow sensor, but the fact is there's one other cleaner that I can use, and let me go get it. And that's this stuff right here. This is air intake cleaner, and it comes with a little red straw on the tube, and I can spray this inside the throttle body once the car's off and it's cool, and I can basically wipe the inside of the throttle plates with a rag. Sometimes I actually like to crack this open a little bit, spray just a small amount in here, wipe it out with a rag. Sometimes I'll even take an old toothbrush, which I would obviously never use again, and scrub the inside of this out and then wipe it out with the rag. And what happens is on the inside here is we end up with a little bit of sludge from when the fuel evaporates after we turn the car off. And this just, helps keep the car, basically fixes the idle of the car, okay? So one other thing that we used to have, with carburetors, there were a lot of adjustments and screws that we could turn to make the car idle higher in case it stalled. And carburetors, because they were mechanical, they had a lot of adjustments. Fuel injection, generally there's no mechanical adjustments anymore. So anytime that we see like a screw that has like this yellow paint on it, that yellow paint should pretty much be an indication for you not to adjust it. If I go ahead and adjust this screw, I may adjust the idle by opening and closing this plate a little bit, but in the process, I'm going to actually confuse the computer. And the reason why is because the computer can't see what I did to that screw. There's no sensor attached to the screw. So if I go and change this and I don't tell the computer is going to be confused. And I guarantee the car is probably not going to idle properly. Okay, so please don't go turning any screws on the throttle body assembly just because it looks like it's what we used to do on a carburetor. Okay? When we come back, we'll take a look at some of the other key sensors and what can happen when they fail. All right, so now that we've talked about the throttle position sensor, the mass airflow sensor, the MAP sensor, let's talk about a couple other key sensors here that we have on the vehicle. The first guy that we're going to have is a temperature sensor. And this pretty much is just a sensor that screws into either the intake manifold, which is going to allow our air to come into the engine, or near our thermostat. And cars actually have both of these sensors usually, and they actually work the same way, but one measures the water temperature of the engine, and one measures the air temperature of the engine, and there's just two little connectors on the inside there where they're going to actually send their signal back to the computer. So what the temperature sensor does is the temperature sensor tells the computer what the air temperature is or the water temperatures of the engine. This is important because as air temperature changes, the density of its oxygen actually changes, which is again going to affect our air to fuel mixture. So knowing the temperature of the engine or the air coming into the engine is a key component. If this guy fails, the car may deliver too much fuel when it's hot or cold, or not enough fuel when it's hot or cold, and in that case, the car may stall. So a temperature sensor is an important part. And fortunately, again, you notice there's no moving parts. So these things are fairly reliable. Okay? The next sensor that we have is this little guy, and this is a magnetic pickup sensor. And this has a small coil of wire inside of it with an electromagnet, and it will actually generate a very weak voltage as a metal object moves past it. So this is usually found on the inside of engines and transmissions, and when we have that metal object swing by, it sends a pulse to the computer and it tells the computer how fast something is going. This little guy is what actually drives the tachometer in your car for the most part. This engine speed sensor may send a signal back to the car's computer, and it's going to tell the car, hey, how fast are we going? okay? The next sensor we have really gets a bad rap, but it's probably the most important sensor when it comes to fuel efficiency and actual overall fuel injection operation, and that is the oxygen sensor. Now, the first thing is the oxygen sensor doesn't really hang out in the oxygen, okay? It actually lives in the exhaust stream, and it's usually located near a catalytic converter. This catalytic converter actually has 2 oxygen sensors on it, and what the oxygen sensor does is it measures the amount of oxygen content in the exhaust of the car. Now, just a quick lesson about oxygen. There's about 21% oxygen around us at all times. Okay, the rest of it is made up of nitrogen and other gases. The car really only uses the oxygen for combustion. Okay, and the easiest way to think about combustion is just like if you were to have a campfire. The more oxygen you put into the fire, the bigger the fire it gets, the hotter it gets. But if I put in too much oxygen, I actually blow the flame out. If I had a campfire in the middle of a windy hurricane, the wind would actually blow the fire out. That's an example of a fuel system that's too lean. There's too much air and not enough fuel to actually run the car. The other side of the coin would be is if I had that same campfire and I took an entire dump truck worth of logs and suddenly smothered the fire with all the logs. The logs were my fuel, but I put so much fuel on top of my fire that I actually smothered the entire fire. That's an example of a car that runs too rich. And the job of the oxygen sensor is to make sure that the car is not running too lean or too rich. So it measures the oxygen content that comes out of the tailpipe. Now, I just said that 21% oxygen comes into the car, but really only about 1% actually comes out of the tailpipe. So this oxygen sensor measures that oxygen content and sends a signal back to the car's computer, and that in turn tells the fuel injector exactly how much fuel to deliver to our vehicle to make it more rich or more lean. It's a very, very fine ratio, and it works out to about roughly 15 parts of air to 1 part of fuel. You know, if your average car holds 10 gallons worth of fuel in the tank, the fact is that I would need much more oxygen. I need a huge oxygen tank to drive around with me. Fortunately, air is around us all the time, so we just pull it into the car, and then the oxygen sensor monitors that. Now, when the oxygen sensor starts to fail, it generally is going to fail in such a way that it tells the car to start adding too much gas. And the reason why car manufacturers do that is because if I take away too much fuel and I make that mixture really lean, I'm going to actually run my car really hot. I may run the car so hot that I actually cause things like pistons to melt. And that's a huge amount of money and a huge amount of damage, and we certainly don't want that to happen. So car manufacturers will generally cause the sensor to over-richen the mixture when it fails. Over-richening the car is generally safe with the exception of you're wasting gas. Okay? So if you have an oxygen sensor problem, you know, make sure that there's not something else causing that problem, but the fact is that the oxygen sensor may be the cause. Okay? In general, these guys will last around 100,000 miles. If you have other mechanical problems like burning oil or burning coolant or a fouled spark plug, they're going to shorten the life of this sensor. So don't be surprised if you end up replacing that at the same time as something else. Okay? So we have our computer. We have the basic sensors. Okay? The next thing is we have a device that is both an input and an output. And this is an older style distributor. And the sensor for this guy, this little magnetic pickup, is right here. When this little vein right here moves past that band, it's going to generate a pulse just like our other magnetic sensor. That's going to send a signal to the car's computer and tell this part, the ignition coil, which is an output, to send a spark to the spark plug and fire our ignition system. Okay? Over here, I have 2 other outputs. This is just a fuel injector by itself. You can see they're pretty harmless and they're not very big. And while they can be expensive to replace, the fact is they generally don't fail that often. They can get dirty over time and then need replacement, but generally they can be cleaned with a special cleaning product that actually gets pushed through the injector directly. The stuff that you pour into your tank or anything like that really doesn't do such a great deal to the injectors. The last piece that we have that's a key output is this is a dedicated ignition coil, which is much more common for what we have today. The coil itself is going to have some wires on it that are going to get connected up to the computer. The computer is going to tell each one of these coils when to fire my spark plug. And again, there's less moving parts. You know, there's no spark plug wires on this to replace. The fact is the plug just plugs directly inside the boot, right inside the coil. So the old days of a tune-up being a cap and a rotor and spark plug wires, they're really gone. These plugs, they can last the vehicle, if it's been running properly, for about 100,000 miles. Okay? So when we come back, we're going to take a look at what's involved with seeing about a problem with the car when the check engine light is on. All right, so now we're going to take a look at just what's involved with actually having a scan tool communicate with the car when there's a problem when the check engine light is on. And the first thing is we're going to turn on our scan tool and wait for it to boot up, because it is basically a small handheld computer. And while that comes on, there it goes, you know, in order to do this, it takes some specialized equipment. Now, you can get a handheld scan tool for $100 or even less now. And what they'll do is they'll just give you a number for a trouble code. Now, that trouble code is going to be correlated with a chart, and the chart may say something like oxygen sensor voltage reading low. Okay, and your first thought is well, great, the car's giving me a trouble code for an oxygen sensor. I'm going to go out and replace the oxygen sensor. But that's not the right thing to do. That's what a lot of amateurs do. And the fact is you really have to understand how the system works. And the fact is that if I have a broken wire on the oxygen sensor, or if there's a leak in the intake manifold with the vacuum tubing or something, that's going to cause that sensor to see a problem. Okay? Remember, the sensor is just the messenger. Okay? And there's that famous saying, don't kill the messenger. Okay? So don't just go replacing a part because you got a trouble code for it. All right? Sometimes you get lucky, and that is the problem, but a lot of times there's a lot more diagnostic work to be done behind it. And that's why you really need to follow the repair manual. Okay? The repair manual is going to take you step by step, and it's, you know, this one starts out, you know, pretty much just start with the basics. That's always where we start in this industry, is start with the basics. You know, we don't just go right to the expensive part and replace it. So now that our system's on, I'm gonna scroll over here and come over to Scan Diagnostics, and I'm gonna pick Global OBD2. OBD2 stands for Onboard Diagnostics Second Generation. The federal government mandated OBD2 starting in 1996 model year, and what had happened before that is that each manufacturer had a different connector, and each car talked a different language to a computer. So a Volkswagen needed a different computer and a different connector than a Honda to actually communicate with the technician. Independent repair shops got really upset at this because they got tired of buying expensive computers and cables for every car out there on the road, and the federal government stepped in and said, starting in '96, you got to make sure all of the cars have the same connector and pretty much talk the same language. And OBD2 helped do that, amongst a whole bunch of other things. Okay, so I'm going to come in here to Global OBD2 and let that boot through there. Now I have a cable hooked up from the scan tool inside the car, and the connector is up underneath the dash in most vehicles. Sometimes it's behind an ashtray or underneath the console, but generally it's somewhere inside the passenger compartment. Okay, so let's see here, I got the right cable, and I'm going to go turn the vehicle on, so I'll be right back. Okay, and now, yep, there it goes. Okay, just had to get rebooted there. So once I'm able to communicate with the vehicle, I have a number of choices. I can either get trouble codes if the check engine light was on, or I can do something known as a data stream. And what a data stream is going to let me do is it's going to let me look at the sensors in real time. Now this is important. Just as a doctor, when you go if you're not feeling good, they listen to your heart, they listen to your lungs, they take your temperature, they measure your blood pressure. They want to know what's going on right now that makes you feel the way you feel. And the fact is a car works the same way. And right here at the top, we can see a couple sensors, just like we talked about. I have my throttle position sensor, I have an engine coolant temperature sensor, and I have an intake air temperature sensor. Now all the sensors are working the way they're supposed to on this car, and if I lean over and actuate the throttle, you should be able to see the throttle change, okay? And that would be an indication that that throttle position sensor is working properly. Now if I have a problem with my air intake temperature sensor, which right now it's showing that it's 97 degrees in the shop, which it is 97 degrees in the shop. If you happen to be watching this when it's a little cooler out, we tape this in the summer. But if I unplug this guy and you watch that number, we can suddenly see that it triggered a code, which means there was a fault recorded in the car, and suddenly now the air temperature, as the car sees it, is minus 40. Now obviously it didn't go from almost 100 degrees Fahrenheit to minus 40 in a split second, but this is an example of just how unplugging one sensor can actually cause a problem and cause the check engine light to come on. Now at this point, it would take nothing more than me plugging that sensor back in, but if I didn't do that and I drove this car around, this car has no idea what the air temperature is right now. It thinks it's minus 40 out, and if I drive this on a 100-degree day with it thinking the air temperature is minus 40, it's going to deliver so much fuel to this engine, this car might not even start, okay? All because one sensor was unplugged. I'll plug this back in here. Okay, and in a second it should, there it goes, now it's showing a little bit lower, cooled off a bit. Okay, so it's important to understand that a couple things. The computer doesn't actually fix the car, the technician does. And that our trouble code that we get is not the end-all be-all answer for the problem. Okay, the trouble code that was just stored when I unplugged that sensor was that there was a fault with that sensor. And yes, there was a fault with that sensor. It lost communications with the car's computer, but that doesn't mean that I'm going to go through and just replace that sensor. All right? So hopefully you have a better understanding of vehicles and the sensors involved with them. I'm Dan Reed. Thanks for watching Car Corner. Drive safe. So just so you know, I'm going to refer to the carburetor as a toilet. Is that okay?
No.
Yeah. It is? Okay. Because that's pretty much how they work. I'm going to explain that that's how.
Okay, that's fine.
Okay.
You're right, Sam, it is.
Hi!
Bring him back.
Nope.
Bring back.
Wait till you hear my
Use the smallest line in the chart. Bring back the tools.